Welcome to quizzes number 2. So now let's figure out a couple of these problems here. So it says that the volume, the change is 3, right? So it's decreasing at 3. So that means the dv dt is negative 3. How about the decreasing, the radius is decreasing at this mark as well. So dr dt equals 0.25, negative. So now it's asking for the radius. So we got to take the derivative here, and then we'll put in the calculator. So dv dt, which is the derivative of the velocity, equals 4/3 pi, which is the constant, and then the 3 comes down, r squared dr dt. We're going to put everything in the calculator, but we're going to solve for r here. So I need to have the dv dt, which is negative 3. I'm going to divide over this part. Actually, the 3's can cancel. So 4 pi. And then I'm going to divide over the negative 0.25 as well. So all that's in the denominator, and that equals r squared. Let's see here. Second plus 712. Let's put alpha y equals 1, negative 3 on top, 4 pi on bottom, times negative 0.25. And then we have to square root that part, so we're going to square root the answer. All right, 0.977. There we go. How about the second one here? A cup of tea is cooling, and it's 70 degrees. If the initial condition is 200, then the tea is changing at this rate right here. So after 4 minutes, right? So this is the fundamental theorem of calculus. The integral of 0 to 4 of the rate equals the temperature at 4 minus the temperature at 0. So the temperature at 0 is 200. So we're going to add that 200 onto the left to get temperature at 4 at the integral of the rate plus 200. So let's take the 200 plus the integral of the rate. 0 to 4. And let's put this into the calculator. It's kind of crazy. So let's go negative 6.89 e to the negative 0.053x and dx. There we go. 175 degrees. That's pretty close. Okay, how about the third one down here? We have a derivative function. So this is the derivative function. We're going to check the interval there. When does it have a relative maximum? So again, it has to go from increasing to decreasing. That's a maximum point right there. But the derivative has to go from positive to negative. It has to be a change in direction there. So we're going to graph this and find out where it crosses from positive to negative. That's the plan. So press y equals. Let's put this into the calculator. X cubed minus 4 sine x squared plus 1. Now it's only from negative 2.5 to 2.5, so I'm going to change that. And I don't really care about going up too high and down, so let's just go negative 1 to 1. Let's find out where it crosses from positive to negative. So look at how it crosses from negative to positive, but right there, that's the one I want, from positive to negative. So I'm going to find that point, second trace 2, and it's this point right here, a little bit to the left, a little bit to the right, and there it is, 542. So 542, that's the only one. It crosses in 3 spots, but that's a min, and then one in the middle is a max. All right, how about this 85, which is the fourth one? A particle moves along the x-axis. This is the position. What's the velocity? So that's the derivative. At the first instant, the particle's the origin, where that's 0. So let's graph this one here. We're going to graph cosine of square root of x. Oops, let's delete that. There we go. So that's the cosine of the square root of x. Let's find out where that's 0. So let's go to window. That's pretty good. Let's just do that. Hey, look at it, crosses right there. I need to move it out just a little bit more, maybe 5 or something. All right, so that's the first 0. Let's find that 0 and store it in our calculator. So second trace 2, a little bit to the left, a little bit to the right, and that point right there, 2, 4, 6, 7. Look at that, it's probably here. Oh, it's not, that's good. But we're gonna store this in the calculator. So I'm gonna go like this and press store as my A. So now let's go the derivative of this at that point. So math 8, derivative of x of my y1, so I'm going to go my y1 at my point A, negative 3.8. Ah, not bad, not bad. All right, so we have this function which is the derivative function. How many relative extrema does it have? So how many mins and maxes does it have? How many times does it cross the x-axis? So let's go to the calculator. We're going to put this in the calculator, and I have 3 minus 2x minus x squared. And now let's put in sine of 2x minus 3. So this right here between negative 4 and 2, so my window is going to be negative 4 and 2. And the question is, let's go like negative 4 and 4 or something. How many times does it cross the x-axis? Actually, negative 1 to 1 to really see where it crosses the x-axis. How many times does it cross? 1, 2, 3, 4, 5, 6. And there we go. Cross 6 times right there. Luckily, because I can barely see that one, so I had to zoom in a little bit there. All right, 89. So we have this volume from a graph, and we're going to rotate it around the y-axis. X is 5, so it looks like it's this curve right here. It's the x-axis. That's kind of crazy, so I'm going to square it. So x squared equals y minus 2. Add 2, so y equals x squared plus 2. So that's the plus 2. There's my x squared, and it's going to go right across here. It's going to rotate around the y-axis. Now that's hard to do without a calculator. It's hard enough without a calculator. Now I do it with the calculator, and it's just kind of hard because there's a y equal or x equals instead of y equals, but this is exactly the same thing as that one. So we're going to pretend like this is an x. So now I just have to go from 2 to 5 with this one squared with a pi. So let's clear this out. Let's do math 9 from 2 to 5. Oh, I forgot the pi. So how to enter the pi, let's just clear everything. So second pi, and then we put the math 9 in there from 2 to 5. And it's this thing squared. And since it's the square root, I'm not going to worry about the square root because I won't worry about the square. So they just cancel each other out. And there's my final answer of 14. Not bad. Now this one is the toughest problem that I gave you. And I'm sorry I gave it to you so early. We have not done this kind of problem yet, the population problem. This is called the differential equation problem. So there is this equation and also the knowledge that it doubles every 12 years. So we got to find the case. Now this is how you do it. Now we haven't done this problem before, so let's kind of see what this is all about. We know that let's go to the very top here. The derivative of the population over time is the k population, right? We also know that the population at the time plus 12 years equals 2 population, right? That doubles it and stuff. So I know those two things, and this is called a differential equation where we're going to separate, integrate, solve for c, solve for y, and it's just a kind of a mess. So I apologize right now. You're not getting too much information from me on this, but we have to kind of separate the dp and the dt. So I'm going to put the p onto this side, dp, I'm going to divide by p on both sides, right? And I'm going to multiply by dt on this side, so k dt. So now I have the dp on the left and the dt on the right, and we're going to integrate both of them. When I do that, I get the natural log of, oh, I don't know why I put the ln, but anyway, the natural log of p equal, and population is always positive, so we're going to worry about that, just positive, and then kt, and then plus a constant that I'm going to combine with both of those. To get p all by itself, I need to e it on both sides, and I get e to the, oh no, e to the natural log, that cancels out. So p equals e to the kt plus c. That's kind of a big deal right there. And now we need to kind of know what that is right there. So it's kind of crazy. So I'm going to put the p, but I'm going to change this to 12 plus 12. So e to the k t plus 12 plus c equals now 2 of them, right? 2 to the e kt plus c. So if I'm going to distribute this right here, I get e to the kt plus k12 plus c equals 2e to the kt plus c. Now look at how this kt plus c, they're both there, but this one's not on the right-hand side. So I'm going to take that part out right there. So e to the 12k, let's just call it 12k. And then there's e to the tk plus c. And then there's the 2 here, and the e to the k plus, or it's the tk plus c as well. So this part I'm going to divide out, and it goes away. So I have e to the 12k equals 2. How do I get k all by itself? That's a k. I need to ln both sides, natural log both sides. And I get, that cancels out, 12k equals ln 2. To get k by itself, I have k equals ln 2 divided by 12. Wow, all that work, right, for that. So we're going to have ln, oops, not that one, ln 2 is that, divided by 12 is that, 0.058. So I bring back my answers, which are right here. And there it is. Now again, that problem is called differential equation. I haven't done that yet, so we're going to do that soon, but just not yet. Sorry about that. We have one more problem to do on the second quizizz assignment, and it has to do with this number 83. And it's asking about, this is the velocity given, right? And if we integrate all this from 0 to 8, you find the distance, the total distance traveled, right? So that means I'm going to add up all of these sections here, right there. How much is that right there? That's 1 times 10. So each one of these is 10, right? So I'm going to count them up, and hopefully I get a number close to this. So this is 10 here, 20, 30, 40, 50, 60, right? But that's like 65 then. 60, 70, 80, 90, 100, and then, I don't know, 110, 120, 130, 140, 150, 160, 170, 180, and then this is like, I don't know, almost 190, 195, 205, a little bit more, 210, and I like that answer is my final answer. Pretty good. Good luck.